This year we decided to take a slightly different tack into the question of what architecture is by really looking at a series of projects that are being carried out within our campus. And they have to do with the capacity of a school to not only to produce academic content, but also kind of like start engaging into real life or real world problems and provide kind of real, very tangible solutions to it. I had the chance and the honor over the years to participate in our outreach program, where you kind of partner up with institutions in the city and you kind of get to, from our SCI-Arc community, we get to kind of not only design the project but also execute them. I think that process actually I think peaked with the advent of the Solar Decathelon program to SCI-Arc. This is our second edition of the Solar Decathelon. It's basically kind of like a partnership between SCI-Arc and Caltech, where we kind of merge two disciplines together to produce some of the most sophisticated architectural solutions out there. I'm going to ask our couple of students. You please explain a little bit kind of what year you're at and so on. But I think kind of the mission of the school kind of really building real solutions out there and kind of like trying to kind of bring the benchmark of efficiency in design kind of like one step further is kind of like an incredible, enticing and question for us to resolve. So please welcome the Solar Decathelon team.
Hi, how's it going? We are the Solar Decathelon team, or pieces of the Solar Decathelon team. My name is Daniel. I actually am now a SCI-Arc alumni. Just graduated in April. I did the full 10-semester, 5-year program. Actually had Alexis for my 3rd-year studio instructor. And I'm here with Kristy.
I'm Kristy. I am 5B. I'm currently doing my thesis this summer for Solar Decathelon, and I'm the construction manager on the project.
And my name is Ella. I'm a Caltech alum. I just graduated in June, and we're really excited to be working with SCI-Arc on this project. So it's the U.S. Department of Energy Solar Decathelon, so it's sponsored by the U.S. Department of Energy. And 20 collegiate teams from around the world are tasked with designing and building solar-powered net zero energy homes. This year, the competition will take place in Irvine, California, so just down the street. It used to be held in Washington, D.C., but moving to Southern California allowed us to really design for our own home. The competition will take place in October, so if you're interested, we give up tours almost every day, so we'd be happy to see you there. The decathlon is comprised of 10 different contests. 5 of them are objective, and they judge the performance of the home. So we have to pretend like a family is living in the home, so we do loads of laundry, run the dishwasher, we have to host a movie night, and of course we have to do all of that while still meeting a zero net energy requirement. And then the other 5 are subjective, so the architecture and the engineering merits of the home, market appeal, and also affordability is a really important category. In previous years, they had homes that were like 800 square feet and $800,000, completely covered in solar panels, really just a concept home. But the U.S. Department of Energy really wants this to be about developing technologies that could be put into the market today instead of years from now. And so they've challenged us to design and build the home to cost $250,000 or less. This is not the first time that Caltech and SCI-Arc have partnered together for this project. We also did the 2011 Solar Decathelon, and we built CHIP, the compact hyper-insulated prototype. Obviously, it gets its name from the expression of insulation on the exterior of the home. In 2011, there were over 2 billion total media impressions of the event, so it's a really high visibility. We get to talk to lots of different people in various industries and give tours to the public. There were over 350,000 house visits. And when the competition was over, we brought CHIP back to the California Science Center, and over 9 months, an additional 125,000 people got to go through the home and learn about all of our really cool innovations. So this year, since we built CHIP in 2011, we have to build DALE, which stands for the Dynamic Augmented Living Environment. This is a picture of our team. Actually, at the beginning of the project, by now, we've had over 50 students work on it. We have about 25 core people now, about 50-50 from Caltech and SCI-Arc, and it's all students who are doing this, which is very exciting. And we just like to have fun, but also work hard. So, let's switch it over.
Yeah, I'm going to start by showing you guys a short animation that we put together.
Welcome to Southern California, where the good sun shines nearly every day. It's a place where you can catch a wave in the morning, tee off at noon, and shred the slopes at night. It's a place to settle down without settling down. Now, what if there was a home that could keep up with you? Imagine a home that embraces Southern California's sublime climate and diversity.
Early Californians built dwellings that grasped the beautiful weather that defined the Golden State. Compact, sufficient bungalows with lots of outdoors. Today, that vast landscape is now overoccupied with the suburban McMansion and its supersized excessiveness. With its 4-car garage, empty hallways, and clusters of unused bedrooms and bathrooms, it's a home that fails to consider spatial efficiency and energy usage. DALE begins by distilling the usage of space in the California dwelling while simultaneously sustaining a large area. At the push of a button, DALE has the ability to expand. It is a house that grows and opens up to allow the exterior to become the mid-yard and to increase its inhabitable square footage, all the while remaining capable of compacting and buttoning itself back up for conditioning and security purposes. Maintaining the square footage at a minimum of 600 square feet, we try to maximize design and space efficiency by allowing the user to reconfigure the house according to need. One of the most unique features of our house is the moving canopy. Not only do the modules themselves move, but the canopies above shift as well. The canopies integrate solar PV panels that allow the house to be energy sufficient and act as shading elements and passive ventilation into the mid-yard. The mid-yard capitalizes on the California landscape by integrating a variety of elements such as a wood deck, grass, sand, and water. The interior of the house is also dynamic. Not only do the modules themselves move, but the public and private spaces are also capable of reconfiguration, where suspended sliding partitions allow for various living possibilities. The suspended sliding partitions serve as storage as well as room separation. These can be rearranged to allow for larger bedrooms in the evening or larger common areas during the day and/or for events. The partitions also house additional furniture and a home entertainment system that allows for a drop-down projector to serve as the ultimate movie entertainment experience. From its flexibility to its celebration of the outdoors, DALE becomes a sweet new California typology.
So like Ella mentioned earlier, this is the first time that the competition organizers have migrated the contest to Southern California. The idea of DALE was really born by being critical on the traditional architecture of Southern California homes. We looked at, as you saw earlier, the California bungalows with its compact living space and abundant outdoors, where there were a lot of value in being outside because California has such a nice environment, all the way to the case study homes where large billowing glass made a visual connection from the indoors to the outdoors. So what we wanted to do was take that a step further and allow that experience not only be visible, but experiential or tangible. And so we unlocked that through the home's movement. So because the home is made up of 2 movable prefab modules that run in a rail system, the home is able to open up and allow California to be your living room. And so like you saw in the animation, we have these moving canopies. Since this is a solar competition, we've integrated our PV panels to act as shading elements, as well as these vertical louvers to act as privacy. So in any given time of day, at any given season, you're able to have varying desired levels of shade and privacy and enclosure. So for example, you could set up your house to open up to a sunny morning setting, where you would have the sun come in from the east. A hot summer day setting where you could allow the canopies to enclose your mid-yard space, or even for warm afternoons to allow the sunlight to come in. And of course, the house is able to button up for nighttime and for inclement weather. And so another key concept of our house was that with the home's movement, we're able to be critical on the supersized housing trends, i.e. the McMansion. The McMansion obviously being something that's completely unaffordable, a huge amount of wasted space. Our house is a compact 600 square foot house. With its movement, is able to expand itself and open up to allow California and the mid-yard to become an integral part of the house design. And so what we have here is the California mid-yard that we're calling it. Here, the landscapes also play a crucial part in the design. We have different samples that reference California's diverse geographies. We have a wood deck, a water feature, grass, and decomposed granite that reference the beaches, the mountains, and the deserts. And so what you see here is an image of our kitchen and our wet module. We actually have a commercial-sized kitchen, so it's a relatively large kitchen for a 600 square foot house, and the idea is to really boast the concept of you buy small and you live large. And so everything is very compact and spatially efficient. And on the other opposite module, like you saw in the video, we have the suspended moving partition walls that act as storage space and as programmed collapsible designs that could actually cater to each room. So the dry module is actually divided into our master bedroom, our living room, and our guest office. And so these partitions not only divide the space, but we have program that actually is adjacent to those spaces that caters to those programs. And now let's going to talk about some of our engineering systems.
Okay, so Caltech students have tried to come up with engineered systems that go along with the architecture of the house. So we have to put the solar panels on the roof. So we have a 28-panel photovoltaic array that will generate 23.5 kilowatts. So that should be more than enough to meet the net zero energy requirements, we hope. And we also have a smart home system. So we want to make the homeowner aware of how much energy they're using and where they're using the energy, like which appliances consume the most energy and things like that. So we have a lot of monitoring equipment that will take data, and then we have a data visualization program. So on your iPad, you can see how much energy you're using, and it will also give the homeowner some suggestions on how they can save energy and run their home more efficiently. For example, when it's nice outside, it might suggest that they open the modules up and move the canopies over to provide shading, but then they can have natural ventilation and they don't have to turn on the air conditioner. Our HVAC system goes along with that, so it's smaller than it would otherwise need to be because, well, we have a 600 square foot house and we hope that the homeowner will open the home and move the canopies appropriately. To provide hot water, we have a solar thermal collector, so it takes sunlight and uses that to heat the water, and that way we're using passive systems and it's freely available energy instead of costly and non-renewable resources. And then to give the homeowner peace of mind and reassure them that no one will be hurt when these modules are moving, we've decked the home out with a variety of redundant safety sensors, and that should prevent all injuries, we hope. And so they're all over the place, and we've tried to come up with a protection against any conceivable, even really ridiculous stunts that people might try to pull. And again, we have the home monitoring system, but also integrated within that is a home control system. So you can use your iPad to turn on the lights, start your TV, run the dishwasher, things like that. We try to make it as automatic and flexible as possible. Along with designing and building the home, we have to raise money in order to build the home. So the U.S. Department of Energy gives us $100,000 as seed money, and then we have to raise about $1.2 million over the course of 2 years to complete the project. So that includes the cost of the materials and construction and also transportation for the house. So we're building it in the parking lot, you might have noticed. And then we have to ship it to Irvine for the competition. And we also have some faculty members and like paid students during the summers, things like that. So it all adds up, and we have to raise that money ourselves. So to do that, we have marketing. So we have promotional materials, handouts. We have our own website, which you can visit. It's meetdale.com. And we have lots of information about the project and our team and what the competition is all about. We also have a Facebook page that we would encourage you all to like, and we also have Twitter and other social media things. Along with everything else, we have to come up with a full set of engineering drawings and blueprints and things like that. We have to turn that all in. We have to build the home to code. We have to have inspections. We have one tomorrow, actually. So it's a serious building project, and we have to put together our own construction schedule. We're a little behind right now, but hopefully we'll fix that in the next couple of weeks. And we just have fun with the project, and hopefully we'll get it done. Thank you for your time. If you have any questions, we can try to answer them.
Yes.
I think I forgot to mention in my introduction that you guys made an amazingly efficient system. We want to know everything that goes wrong. We want to know about the difficulties of actually executing architecture. That's a little bit of what we're looking at. We discussed that with Marcelo last week.
Right.
We're like, you're trying to make a tent. There's a whole bunch of things that they work, they kind of work, and I think there's incredibly pedagogical opportunities to actually find new problems and new solutions as we develop.
Right.
So if you guys don't mind, kind of try to open up the other side of the story, which is how we discover, address, and what are the issues that come out that you weren't quite expecting, and all of a sudden became an opportunity for something else. If that's
Sure.
actually happening.
Yeah, I think there's two parts of that answer. I think the first one is obviously just the construction, design, the transition of actually conceiving a concept. Oh, sorry. Conceiving a concept and realizing it, actually figuring out how something like that works. I mean, early on, we had the idea of, okay, let's make a moving house. That'd be cool if we could let the outdoors become inside. How do we do that? Like, what mechanical systems do we need? What details do we have to go into? What engineers do we have to talk to? How do we make these things work? So figuring out all the nuts and bolts of actually putting together a concept in your mind that typically at SCI-Arc, we tend to go off and design these crazy things, but then to really try to understand how it comes together is extremely valuable in this project. The second part is actually marketing, and so for us as architects, it's all cool and moving house is awesome, but for Joe Schmo over here who thinks to himself, oh my gosh, you have a moving house, that means more moving parts, that means more maintenance. How do you convince someone like that? And we have, in our contest, like Ella explained earlier, we have market appeal, we have communications that are part of this competition. And if we do poorly in those contests, we will fail. And so we are constantly battling, not only figuring out how to build this project, but also how do we strategically present ourselves and execute this thing. So there's two parts.
Yeah, I think that the way we went about it is most of these things are available in industry already. It's just finding a way to repurpose them and use them out here. So we've, for the plumbing systems, we've gone from cable reels to loose plumbing to now going to cable carriers and just trying to figure out what's the most efficient way to do it. And that's probably been the most difficult.
I mean, a lot of research has been
You're
done.
saying that moving plumbing is difficult?
Yeah.
Okay, so that's something that probably when you say like this move, these modules around, that's not the first issue that came up. But
No,
it's kind of
exactly.
one of the most tangible problems to resolve.
Exactly. So problems like that would always creep up on us.
Right. Yeah, we looked at RVs, like how do we make this work? Because we didn't want to give up on the movement or have one part that's fixed. Like the kitchen's fixed and the bathroom's fixed, everything else moves. So that was.
And also on a side note, Ella mentioned that they introduced the affordability contest. Another huge lesson that we learned is value engineering. We actually, if this is a scheme that we did actually in December, last year in the fall, what they did was they actually gave us a legitimate cost estimation, and based on that, they tell us how many points we're going to get. in the actual competition. So we came out at like $500,000 our first round, and that's when we actually had 3 modules. We had 3 moving modules, and had this crazy, parametric skin that we designed on top of it. But then we realized that, oh my God, like we're gonna fail this affordability. We're gonna get like 0 points. We have to do something about it. We have to go back to the drawing board and design a house for 2 modules, essentially cutting off 1/3 of the price. So stuff like that is a very real, very problems that emerge that we have to deal with unless because we don't want to fail.
Right.
So.
And now the last cost estimate that came in, we're right at 200, which was a very pleasant surprise.
Right.
We all did backflips.
Right. We learned that there's like a psychology to how they do cost estimation. Like once you stop throwing curves everywhere, things get like a lot cheaper.
Yeah.
So.
So how much is that final? How much does it cost?
Well, they won't give us the final cost estimate till the competition. It's one of the contests. So the one based on the CD set, we're 213, I think.
Can you guys talk a little bit more about, I know that this is like a 2-year program. Can you guys talk a little bit about kind of how that fits within a curriculum? I know there's teams that they kind of move through the development of the project. I don't know how that works with Caltech, but if you guys can kind of explain a little bit kind of pedagogically what does the program fit and kind of how do you make it work?
Sure. Well, for me personally, and I guess Kristy as well, we joined this project towards the end of our education here. So this project started in early 2012 in January for my 4B semester, and so I jumped on right away right when it started, and so I've been involved for the past 2 years. And I think for me, and Kristy could probably agree with me, that it's a great way for you to take all your knowledge and all the theory and all the design that you've accumulated and to really understand how things get built. Like how to put it together at the end of the day, how to put together a legit drawing set, how to explain to a contractor how to get something built, how to work with a team. We have, like Ella mentioned earlier, we had, over the course of 2 years, we have about 50 students. Right now we're about 25 or so. But yeah, students have come and gone. Some people are here more committed than others. Working with a team is actually pretty tough for something like this.
Design by committee is never
I'm not sure if you guys are working in partners yet or if that's anything implemented. You guys will. And working with one person is something, but working with a team of 20 is insane.
And, the engineers and the architects come from 2 totally different backgrounds.
Yeah.
So what they want and what we want is never usually in line. So it's a lot of compromising or arguing one way or the other to get it built. Because at the end of the day, it has to get built. You can't just be like, oh, we disagree, we're not going to deal with it.
Exactly.
So it's difficult.
Yeah.
Talk a little bit about like what, for example, your involvement is architecture, specifically, like were you just producing working drawings or how much of it
Right.
have you been involved with?
So
A little bit of everything. There's some people that are obviously better situated to do some things, but you can't say that's not my job, I'm not going to do it. So you have to do everything. We're out there. I don't know if we're going to tour out there, but we're out there.
yeah,
Yeah.
we're definitely gonna tour out there.
Yeah.
We'll definitely show you the house. But it came in stages. At the very beginning, our studio is up here, up in this little, we're calling the penthouse suite up here. But every student was involved in design to some extent. We actually had 5 schemes where we came onto a vote, right? And so at the beginning, yes, it's very, very heavily design influenced, but after a while, we actually have to build this thing. So now we have very delegated teams for construction, like Kristy's managing the construction aspect of it. Right now I'm doing like a lot of the drawing set and like the animation stuff. Yeah, exactly. Caltech is working with all the components and technical, electrical MEP components of that. And so as time progresses, everyone has their specialized roles. And so right now, every student essentially has their own, little baby projects that they're taking care of. For example, the moving cabinets, that's like 4 students are on that because they've designed it from the beginning. They have to take care of the material takeoffs, they have to order the material, find out how to weld it, put it together, use the wood shop if they need to, and get it done. So everyone is taking care of their own little projects.
So that was the question I had too, is like how much students are involved in the actual building. Yeah.
Well, we'll go over it out there. We subcontracted, the steel, the concrete work, and some of the interior framing, but the rest of it we're pretty much doing ourselves. Like we're welding the canopies. We have some help because none of us really knew how to weld all that great, and they're sliding around everywhere, so you don't want that to happen. And then the Caltech kids are doing the MEP stuff, but we're physically out there doing,
Yeah.
I would say 80% of the
Yeah,
work,
yeah.
probably.
You want to speak to that?
We're a little short on our fundraising. Some of what we do is we pursue in-kind donations instead of just cash donations. So we're still in the process of trying to get companies to donate their products as we move along. I don't know that we've tried to do any crowdfunding, but actually that's not a bad idea. At this point, it's probably a little late, but we might do that in the future.
Yes. The waste. Okay. Well, you want me to answer in terms of the actual competition, or how would it be in theory? Okay. So for the competition, they require us to have water tanks, and so we have one supply water tank and one wastewater tank. We get 800 gallons to begin with, and at the end, we spend how much we want. That's our allowance. And so we have water bladders that are hidden underneath our landscape, and those hoses are connected through a cable carrier that gets attached to the back of our mech room. And so the cable carrier allows the flexible hose to move along with the building. And so all of our waste from our bathroom, which is on the south end of the building, we're actually using this thing called a macerator. It macerates our waste and sends it up through the roof into our mech room and then out to our waste bladder.
But for the competition, none of, like, the toilet's not used,
Yeah,
the
exactly.
shower's not used.
Yeah.
And in a regular setting, the out fee would just be connected to the city, whatever situation you're in.
Yes.
What happens to the building after the competition?
Right now, we initially had some, agreements with California Science Center, like we did with CHIP. But right now, I think there's some fundraising issues. Pretty much like there's no one to really pay for the logistics of the transportation. And so right now, there's not really a set plan for it. So most likely, correct me if I'm wrong, they're probably gonna come back here immediately afterwards.
Possibly. We're also, we have at least one person who might be interested in buying it and moving it to the Caribbean somewhere. So,
Humidity.
Yeah, or that.
yeah, we'll see.
Yes.
Do the walls of the house expand also, or is it just the panels?
Are you talking about for the canopy, or?
The exterior, I mean, like, when it's expanded,
Right.
can it be enclosed completely, or is it open?
No, yeah, it will never be technically enclosed. When the modules are separated, it's open air. And so when we're calling it closed, we're saying that the canopies, create a experiential space where you have shade, and privacy and stuff like that. So it's not necessarily fully sealed. It's just open with canopies shading you.
But there's louvers on the side that you can open and close.
Right.
Like, if it were rainy or cold, would it have to be closed?
Yes. Yeah. Unless you want to get wet. But yeah, you would most likely close it in that situation. Yes.
How wide are the structures, and how did you obviously knew you were going to have to transport it? Did that factor in primarily in the design, or was that kind of a side effect?
It was a factor in the design. I mean, I don't know, primary, but not, it wasn't like a side.
Well, it was something that had to be constantly in design. So, for example, the competition itself, the minimum square footage you could go is 600 square feet. The maximum is 1,000. So we deliberately made our floor plan to be exactly 600 square feet to really accentuate the argument that you buy small, live large, right? So we designed our steel structure to be relatively fit on a long bed truck. But then because of that design concept, we actually kind of tweaked the structure around to make sure that it can still fit on a truck, but then be exactly 600 square feet. So it's like these types of little conversations that are in constant conversation with one another. And like, for example, like to talk about the structure, to get from our landscape into our building has to be by code 7 3/4 of an inch to make it a step. So we have to design a structure that are able to have that thin floor plate, but then still be substantial enough to not be in risk of any earthquakes or anything like that. So our structural engineer created a truss system where we have like a wide flange up top, like a really tall top member and a really shallow bottom member in order to create that truss system that'll be stable enough. So it's all these small little details.
Was there a student who designed the structure, or did you get it?
It was, what we did was
Schematic.
it's schematic. So we just draw like what we think we want it to look like. We were working with Bureau Happold, they're out in Culver City, and so we have a structural engineer on their team pretty much. And so we go over there, we talk with him, and he pretty much calcs it out for us and draws it for us what would work.
Does Caltech have any say on that, or you guys don't have any civil engineer?
No, they don't, Caltech doesn't have.
We don't have a civil engineer.
No problem. Yeah.
No.
Yeah, they're only mechanical and electrical.
And chemical.
And chemical, and nuclear and everything else.
Big Bang Theory.
Yeah.
Big question. Like, the whole competition moved to Irvine, like, so all from around the country, people are gonna.
Right.
And there's a team from the Czech Republic and from Vienna, I believe.
Yeah, so it's an international competition, so all houses get shipped to the competition site. And so lucky for... Yeah. Yeah. Used to be in DC, yeah, exactly. So I mean, we kind of got lucky because it's right down the freeway from us now.
Yeah.
I think the Vienna team and Czech Republic team are actually on a boat right now.
Yeah.
Like, you know.
So that made your construction schedule.
Yeah, yeah. I made it a little more lax.
I don't know about that.
Awesome.
Cool.
Can we go and take a look?
Yeah, yeah. We'll go and check it out outside.